So I would like to start this video on implicit differentiation and related rates by summarizing what one needs to do in order to differentiate implicitly. So step one is to differentiate both sides of the equation with respect to x. In doing so, you'll have to apply all the appropriate rules, the power rule, the product rule, the quotient and chain rule, and then anytime an expression involving y is differentiated, dy by dx will be a factor in the result. Next, you should isolate all terms that contain dy by dx on one side of the equation and move all of the other terms to the other side. Then, on that side of the equation, you may need to factor out dy by dx. It might be that there's only one term with dy by dx in it, in which case it's not necessary to do any further factorization. And lastly, you may need to divide both sides of the equation by something in order to solve for dy by dx. And that's the procedure. So here's an example from the homework. It's number 9 from section 2.8, but the problem says differentiate implicitly to find dy by dx and then find the slope of the curve at the given point. So the equation is x to the fourth minus x squared y cubed equals 12, and the point in question is negative 2 comma 1. The first step is to differentiate both sides of the equation, and so I have prepared to do that by noting that the derivative of the left-hand side with respect to x must be equal to the derivative of the right-hand side with respect to x. And the next thing I will do is differentiate the left-hand side with respect to x and then the right-hand side with respect to x to get a new equation. So let's do this slowly. If I differentiate the first term on the left-hand side, that's a 4x cubed. And then I should compute the derivative of the second term, but I'm going to do that very slowly, minus the derivative with respect to x of x squared y cubed. And that equals the derivative of 12, which is 0. Okay, so I've rewritten the 4x cubed, and now I have to subtract the derivative of this term, which is a product. So I have the derivative of the first term, 2x times y cubed, plus the first term, x squared, times the derivative of the second term. And the derivative of the second term, it has a y in it, so I do 3y squared, and then I have to multiply that by dy by dx. And that equals 0. The next step is to isolate all of the terms that have dy by dx on one side of the equation. In this case, there's only one term, which is right here. And so I want to isolate that term and move the other two terms over to the other side of the equation. So first, I expand out this negative sign through the parenthesis to have 4x cubed minus 2xy cubed minus 3x squared y squared times dy by dx equals 0. And then I'm going to add 3x squared y squared dy by dx to both sides of the equation, so that I have 3x squared y squared dy by dx on the right-hand side of the equation and equals 4x cubed minus 2xy cubed on the left-hand side of the equation. The last step is to just divide by this quantity 3x squared y squared. Okay, so I divide both sides by 3x squared y squared, and this side, of course, everything cancels, and this tells us that the derivative is equal to 4x cubed minus 2xy cubed, all divided by 3x squared y squared. Okay, so in this little box on the right, I'll finish with the second part of the problem, which asks us to find the slope of the curve at the given point. So all we have to do is plug the coordinates of this point into this formula down here. So at the point negative 2 comma 1, we have that the derivative is equal to 4 times negative 2 cubed minus 2 times negative 2 times 1 cubed divided by 3x squared y squared, and I've just plugged x equals negative 2 into this equation down here at the bottom, and I've plugged y equals 1 into that equation. And now I just need to simplify, and you should double check that the correct simplification gives negative 7/3. And that is the slope of the curve at the given point. So to see locally what's going on, here's the xy plane, and I'm going to put the point -2, 1 there. And the slope is negative, and so the curve happens to be doing something like this. And that's a local picture of this function. Okay, so let's do another example. This happens to be number 21 from the exercise set of section 2.8. And this time, the derivative with respect to x of the left-hand side is got to equal the derivative with respect to x of the 11, but the derivative of that's 0, so I just wrote that out directly. And now I need to apply my derivative rules, and every time I have a quantity involving y, I have to add the factor or include the factor in dy by dx. So let's watch this in action. The first term here is a product x squared times y cubed, and so I'm going to differentiate that by applying the product rule. 2x times y cubed, that's the derivative of the first term, times the second, plus x squared times 3y squared dy by dx. That's the first term times the derivative of the second, and I've included my factor of dy by dx as needed. Now I need to differentiate this second term here, and it's again a product rule, and so I have 3x squared times y to the fourth plus x cubed times 4y cubed dy by dx, and that equals 0. So now in one fell swoop, I would like to subtract the 2xy cubed from both sides and subtract the 3x squared y to the fourth term from both sides, and group together the pieces involving dy by dx. Okay, so I have written out this term. It's got a 3y squared and an x squared, so I wrote that as 3x squared y squared times dy by dx, plus this term, which has a 4, an x cubed and a y cubed times dy by dx. So that's the second term appearing right here. And then on the right-hand side, I have these two terms written out. Okay? So 3x squared y squared dy by dx plus 4x cubed y cubed dy by dx equals -2xy cubed minus 3x squared y to the fourth. And the next thing to do is to factor out the dy by dx. Okay, so I have a common dy by dx and then times 3x squared y squared plus 4x cubed y cubed. On the right-hand side, it's going to be useful to simplify the right-hand side, so I'm going to factor off a negative sign and a power of x, so there's one x that's common to both terms, and a y cubed that is common to both terms, and what remains is the quantity 2 from this first term and a plus 3xy from the second term on the right-hand side. So I'm going to take and rewrite this last equation on the next slide. Okay, so here's the equation that we established on the previous slide, and the last thing to do is to divide by this factor here so that we can isolate the dy by dx. And there I've written it out, so I've divided both sides by the quantity 3x squared y squared plus 4x cubed y cubed, and on the left-hand side, the two quantities, the numerator and denominator, cancel, and on the right-hand side, well, it's there, and it's actually useful to, again, factor off a power of x and a power of y. So in the denominator, each term here has a common factor of x squared and a common factor of y squared. So if I factor out an x squared times y squared, from the first term I still have a 3, and the second term I have a plus 4xy that still survives. So then the formula for the derivative dy by dx, I'll rewrite it. So here it is rewritten, and the last thing to do is to simplify, so I should be able to cancel one power of x in the numerator from one of the powers of x in the denominator, and similarly this one power of y should cancel with that. Let me rewrite this as -y times the quantity 2 plus 3xy, all divided by x times the quantity 3 plus 4xy. And that's the solution to this problem in final form.